Hello, good morning. Coding Garden fan, hello. I love those. I love these emojis. Oh, and those are the CJ emojis back when he had his hair shaved. And that and oh hi. I don't know if I'm familiar with that one, but good morning. Hopefully your day is going well so far. We are here to continue deep diving into Rust arrays. And so I've been trying to think about like how I want to organize these, and probably have, because the standard library has a very standard way of organizing things. So I sort of feel like that it's going to be pretty easy for us to create these as what is it called, like a template of some kind, and then use that, which I kind of like the idea of. But continuing on, okay, so we're on auto trait implementations, which is here. And this is array, yes. I feel that something's wrong. Don't I normally get colors? Yeah, yes, I do. Okay, so ref unwind safe. I don't think I'm familiar with that one. A marker trait representing types where a shared reference is considered unwind safe. This trait is namely not implemented by unsafe cell, the root of all interior mutability. This is a helper marker trait used to provide impl blocks for the unwind safe trait. So unwind safe. A marker trait which represents panic safe types in Rust. This trait is implemented by default for many types and behaves similarly in terms of inference of implementation to the send and sync traits. Oh, interesting. Okay. We're probably going to get into unwind safe when we go into the traits, so I'm not going to go in too deep right now. But all right, that's cool. So ref unwind safe. So in this case, we need to head back to this. Don't need to keep that open. Traits. So this is going to be here. Ref. Oh, font page. Ref. Mind safe. We also, okay. I also need to make sure these are in alphabetical order, just to make it easier on myself. So copy, clone. I need to get rid of this block. Because if I try to move, well, I can move you out. Okay, that's what I need to do. I need to move these all out. Let's debug into iterator that should equal order. Okay, order hash. Ref, mute, borrow, mute, and and something. Okay, now you go away. Okay, so something. I don't think there is a something trait. Something tells me there's no something trait, so I'm gonna get rid of you. But okay, default there definitely is. So default. Ord index. Index mute. And then, okay, so here with that. So this ref unwind safe. We got that. Send. Sync. And T is ready. Well, sort of ready. It's still too hot. Let's see. Sync unpin. So I saw a thing a long time ago from John Hu about pinning and unpinning, but I forgot everything about it. That's gonna be fun to go back into. So unpin and then this unwind. Safe. Okay. So then we can go back into primitives, go to arrays, and down here for auto traits, we're going to now add ref unwind safe, if you can find it. There it goes. Okay, so those are our auto trait implementations. And I'm mostly doing this, like, I know I'm copying like a lot of it. The notes is like the most important thing for me. And I guess the methods. The trait implementations is interesting, but not that interesting, but I'm using this to like make sure I get all the traits copied down properly. Although maybe we don't need to actually go through that. Maybe I don't need to really do this. I don't know. Because the trait section has this, right? Yeah, traits just has all of these. So things like, okay, any, unwind. Oh, it has like who owns them too. That's nice. Okay, see here's like ref unwind safe from panic in the panic. Okay. Yeah, in that case, I don't think we need to store these because I'm just gonna get rid of these. We're gonna be doing traits later, into like deep diving into those specific traits. For this one, it's basically just going to be deep diving into arrays, how to create them and all that stuff, which I think we have now. So the big thing is the ways to create, the 2 ways to create arrays. That these traits are available to us. In the case that you need them. I almost feel that I want to convert this back. Oh no, I can't. And let's see, can we extract all values from the array using structuring like syntax? Right, I think that's nice, which is basically using a pattern. So I think those are the big things, and then the methods we're going to ignore. All right, so what I'm thinking about is we have this sort of like the live raw stream that we're doing, and we also want to sort of like do a recording on just arrays, and we're just going to go into there. So we have, I don't want to reset this. Let's remove you from the workspace. Okay, so I want to create it as a library this time. So what do they call this? Exploring Rust standard library. Remove. Is there like a remove dir force? That. Positional parameter can be found that accepts the argument. Okay. Can I do remove? You're gonna tell me it's still full, right? Oh, the item is chosen. Oh, the recurse. That's what it was. I still want to continue. Yes. Cannot. Permission denied. Cool. Yeah, okay, because it's not empty. I always, you know, it's just easier for me to do this in Linux. I'll just force it. I forget the PowerShell commands. I so rarely use them. Okay, so here is exploring Rust standard library. So we're going to do a rm-rf exploring Rust standard library. There, it's gone. Now it can come back to here again, and we're going to do a cargo new. I'm going to do a dash lib. Is it dash lib or dash lib? I can't remember. And we're going to do the same thing. Exploring Rust standard lib. It is dash lib. Okay. So then we can use examples for each of these things. So opening you back up, let's re-add you. Exploring Rust standard library. Here's our standard library as it is, which means I should now be able to. Yeah, of course you hate this. I don't care. I think it's in here. We can do a folder for examples, and then we should have like arrays, rs, and I think we need just like a main function. Main, and if I just do a echo, no, I think I can just do like a print line. Yeah, hello world. So can I do cargo run sample arrays? Yeah, so then it runs this examples arrays command. So this is how we can put all of our stuff inside of here. And then I have my notes over to the side. Okay, and then up to this. All right, let's do this recording. So I've been starting to deep dive into the Rust standard library, and first up is Rust arrays. I'm really just starting with that because, well, it's first in the alphabetical list of the primitives. So let's dive down into like what I've discovered. Now I'm also live streaming all this, and I have over in the playlist for just like the uncut raw live streams. You can just see all of this yourself if you want, like my exploration process instead of just this summary of what I found. All right, let's get into this. To begin with, arrays are just a data structure we can use in Rust. It's very similar to vectors, which we'll obviously get into a little bit later, in which that it's kind of like JavaScript arrays or like Python lists, and then I think arrays from other languages too, in that we can have like a series of things next to each other. And also, like any other strongly typed libraries, they must be of the same type. But that's probably not the most interesting thing about them. There's two ways that we can create arrays. We can create them as just like, well, just creating them with the data in it. So let, I don't know, names equals, and oh, here we go, exactly like this. So we see an array, literal syntax here, and then just 4 names that go in. This array now is size 4. It's going to be size 4, and that's it. Like it's size 4. And also, as we can see, Rust Analyzer telling us it is always going to have static strs inside of them. That's it. That's what this is. You can't really change that. However, we have another way of dealing with this. We could say something like let number or zero, let's do zeros. Zeros equals an array. Well, exactly like this. We have an array. We have the 0 that we want to create, the semicolon, and then the number of elements to create. So now we have an array of 5 things, but they're all zeros. And in this case, they're all I32s. We can change this by changing the 0 type. I can make that like a U32, and that's perfectly fine, and this works just great. Now we can do this to our own types too. Let's say that we wanted to create like, you know, a type of size or something. So let's create a tuple struct really quickly. So struct size that has maybe like a U32 in it. And if I put this in here, and we're just going to put in like size, well, that's not going to work because it actually needs a value of some kind in order to deal with this. We can put in like a size 0, but this is still not going to work because the way behind the scenes what's happening is in order to create these, it's copying them. So it's saying, okay, you have this size 0, but I now need to copy it 5 times to, well, 4 times, I guess, to really fill out the array. So we need to derive debug, clone, and copy. And then this works just fine. Now, there's a really interesting thing in the standard library here that talks about the arrays of any size will basically implement traits, like these certain traits that are listed here, if and only if they're implemented on every single member of the array. It's sort of like an optional trait almost. It kind of feels that way, but what really happens is we call something on the array itself, and it's going to call this thing on every item in that array. So we notice that copy and clone and debug is in here. So this is the reason why we can now come back to our code and do a debug of zeros. And if I run this, we'll then see the output of it. So it's not the array that's just like figuring out all the debug stuff. The array, yes, can handle debug, but in reality, the array is forwarding on and calling debug on every item inside of it. And so that's why debug is available for us. If we don't have debug here, then this is going to fail because all the items don't have it. So therefore, you can't call debug on the array itself. And then the same thing with clone and copy and all these other things. It's a sort of like it's common sense once you sort of think about it, but it might not be something that's just like you initially think about unless like you just know it. Let's put that back. All right. Now, there's a couple ways to sort of like extract data out of arrays, which is interesting. There's the normal way. So let's say, let's not debug, want debug. There you go, thank you. Let's say I want to extract some of these names out. Well, I can get sort of like a destructuring like syntax for this. I can do something like let John, Jane, Mary, and Patricia equals names. And that now has broken all of these out into their own well, variables here that I can just use individually. So now I can debug John and the rest of them individually. Now, if I try to debug names, I think that's going to work because I have a reference here to them. This would probably not work quite so well if I was doing something that didn't implement copy or clone. And a reference like a string slice does allow me to sort of like just copy those over because they're just references to a certain point in time. Let's create another struct here that doesn't implement clone or copy. So maybe we'll have like, maybe location isn't right. Well, let's do location. I'll show you an interesting thing that we can do with that. We'll do a struct location. You have an X, which is a F32, and a Y, which is an F32. I'm going to derive default on this one, and I'm not going to put anything else in there. Maybe I'll put in debug. Debug will help us sort of like see that later. Now I want to create these up here. So let locations is going to be equal to, and I want to use this shorthand property, but remember, I can't just say like a location 5 of these. That just doesn't work because it needs to be a value. What I can do is do this default. So it runs the default first. And what are you upset about? Oh, it needs copy and clone for this 5. Never mind. I'm going to just do this multiple times. I forgot. I already forgot my own thing. Okay, so we've done this 3 times. So now we have 3 locations in an array. If I wanted to extract some of them using this same sort of method, so let's do let location 1, location 2 equals locations. Now, if I try to debug location 1, that's fine. Let's debug locations. I can't, because we've moved the values out of the array. And so this sort of like almost destructuring like syntax will sort of like take ownership if it can. If it if there's a clone and a copy available, which numbers and string slices and like many other primitives actually automatically implement clone and copy already, then it will do that. It'll just clone and copy right out, and you will be none the wiser. But in this case, we are taking ownership of these locations, and that means I can't use locations anymore. Now, let's say I only want the first one out, and for some reason I don't want to say do like the classic let location 1, like let location 1 is equal to locations of 0. Like that's the classic way of doing it. But now it won't allow me to like move out of here. So that's an interesting way of like moving things out, allowing the borrow checker allows us to do it. It's pretty cool. So what if I only want to move one of these out using destructuring? Because I have to like match everything, right? I can't do something like this because it's going to say, hey, the pattern doesn't match it. Like this, there's 3 things in here. You only have 1. So if I do like location 1 and maybe like underscore, this works. Now we still have this problem. Like we can't do that because it's been, it's got borrow problem. But over here we're just like saying, hey, anything what it is, we don't really care. And it drops its value essentially. We're just have no access to it anymore. And then let's see. We can also, there's other patterns that we can use too. So this is like get the first one. If I don't want to put these other like underscores here, let's say I have like 1,000 items in my array, I can do ... That's going to just say, hey, the rest of them are over there. Just don't worry about them. Give me location 1. And then finally I can do, and this is legal here, a second one where I can do, give me location 3, and that gives me the last location. So now I can debug location 3 out. So this is like many different sort of ways to like kind of sort of destructure out. It sort of like feels right, but the technical term for it is patterns. And I think that's pretty much everything we have. There are a bunch of methods on arrays right now, but they're only in nightly, so I'm not going over them yet. Maybe when they come out, we'll do a follow-up video. Anyways, thank you for watching. I'll see you in the next video. Bye. KJH618, hello. I think we can use location 3 default to get the default for the entire array, even if location is not copy. Let's try that. So, let's, oh, you're doing default afterwards. Okay, after it. So let's war locations is going to be equal to, so this is interesting. We're going to use this. Oh, well, look at that. Okay, location 3, but then call default on it immediately afterwards, and then we're good. So good to go. And I can now just debug more locations. Yeah, so we're calling default associated implemented on the type location 3. Yeah, that's really cool. That allows us to put the type in there, but I guess it's because we use almost Turbofish type syntax here, which is pretty cool. I'll leave this in the examples here. Okay, so that is arrays. What's next in our list of primitives? Let's actually just come down here. Macros, functions. Wait, I missed it. Oh, here it is, primitives. All of you into the pool. Convert all of you into pages. You're done. Now I kind of want to take, so we have like just the general note section. I guess we don't really need to worry about it too much. So Boolean. So Boolean represents a value which could only be either true or false. If you cast a Boolean to an integer, true will be 1 and false will be 0. I mean, that's like pretty classic old school where you can just like compare, but can I actually do like a direct comparison with that? Bool.press. So can I do something like debug 1 is equal to true? Will that work? No. Okay, so it can't do that. Although you're not yelling at me anymore. Why are you not yelling at me? Yeah, expected integer found bool. But I can cast it. So I can do dot into, I think. And then it works. Because I'm casting this into whatever it needs to be, but it can become that. And this, I think, can be anything, right? By default, it's like an I32, but this can be like an F32. No, probably not an F32, a U32. And this still works. So, no. did not want you to turn into that. I don't know how to like undo this now. Okay, Boolean, you're dead. Empty. Sure. Okay, so Booleans. Can be cast into a 1 or a 0. Bool implements various traits such as bit and, bit or, not, etc., which allow us to perform Boolean operations using and. Well, I guess bit and, bit or bit not. Now, really, on Booleans themselves, because you're 1 and 0, because you're essentially binary. If requires a bool value as its conditional. Assert, which is an important macro in testing, checks whether an expression is true and panics if it isn't. Okay, so here we can do this like these bitwise operations, which is interesting. So we can do true and false, which gives us, I mean, false, because I think with and they both have to be ones in the right place. There was not also, right? Not is, oh, bang is not. Now, it's important that, like, when you're using non-Booleans, you have to use, like, and. Because if you use just one and, it's a bitwise operator, which looks at the binary values, and that can be a bit strange. But yeah, they're just binary, so we can totally do that. Although I don't know why I would want to do that too often. Like the only time we've used bitwise stuff is with like the bit mapping. And that was not on Booleans themselves. That was on numbers. A trivial example of the usage of bool, praise the borrow checker using the if conditional. If praise the borrow checker, print line, ooh yeah. Oh, I think I forgot to record the previous one. That's gonna be not fun. Else, okay, so, or a match pattern, right? So you can match them too. Also, since bool implements the copy trait, we don't have to worry about the move semantics, just like integer and float primitives. Now, an example of bool cast it integer type. So I guess like the big things is used in if and match statements, and asserts, but if match statements and asserts. Implementations. So like then some is, okay, so. Oh, interesting. Look at this, it's backwards up here. Then some is nightly only. That could be nice. So we have methods. So there is then some. Oh, this is nightly only. And maybe up here we're gonna just do then. Okay, returns some function if the bool is true, or none if otherwise. So false then this thing, true then. Oh, so it's gonna be none if it's false. So it returns an option. I didn't even know this was a thing. Let's see. So we can do like let x equals true. Then I want to say like let y equals x dot then. This has to be a function which doesn't take anything in and is going to return whatever I want this to be. So like if it's true, if x is true, return something like, I don't know, 10. And now y is an option with that in it. So I can see this being helpful potentially if you have like a struct that you have like a flag on it for like is alive or something else, like get the health. And if it's alive, give me the health. So because that way you can just have the method, like a method on the struct would then say, okay, we have our just like is alive, check that out, and then if it's true, and then you probably don't really want to do something like anything like this. You probably want to say something like x equal. Let's reset this. We're gonna do something like let x equals 5. That y equals 10. And then it will be something like let first because I can see damage, like if you're trying to damage each other and you want to see like did you die, do you have like a new health, or are you just dead now? So let's do A health. You're gonna be B health. And you're that. And then A health, or A health damage is B health. So let new A health equals, and so it's gonna be A health. So it's gonna be A health minus whatever the damage from B is. So like me damage is maybe like 10. Each one does like 10 damage. So we do that minus, and then that has to now be greater than 0. I then take this entire thing and I can then do a dot then. If it's true, I want the new health to be a health minus 10. And I have this option now. I would actually, like, it's a feeling kind of forced. It doesn't really feel like it's actually useful, like now that I have it written out. Because like I can just have the flag there and just check the flag and just remove everything. And that would be it. It is something that can be done, but I haven't. Yeah, I can't think of like a super good use for it now. But knowing that it exists is probably step one. So then, this allows us to write a closure to return a like any value and an option in the case that an option okay, so we do something like this, and now new A health is actually none. So we can assert that new A health is equal to a none. Kind of want to do assert equal. Okay. And then we're on to trait implementations. Okay, cool. And is there anything else we care about here? I don't think so. All right, let's try the next one. Go over there. All right. Next up, we're talking about Booleans here in Rust. They're, they should be pretty simple, right? Like Booleans are just a true and false value. They're in pretty much every language that I can think of. And there's a couple interesting things that we can do with them in Rust. So to begin with, like many other languages, they can be cast into a 1 or a 0. However, they cannot be directly equated to. So for example, I can, if I do like a debug, 1 is equal to true, this is going to fail. We're going to get this comparison error where, hey, we can't compare a integer I32 with a Boolean. That just doesn't work. But I can do a dot into, and then that does work. So I can cast true into any sort of like any number version of 1. So that would be something like a U32, a U8, a U size. I don't think I can do a 1.0 F32. I don't think that's gonna work. No, it has to be something that doesn't have a decimal point. So no floating point numbers here. And that's interesting. And it's good to know that you can't actually like directly compare it. So if you have something in the database where you're storing your Booleans as like ones and zeros, then you are going to have to be careful if you're trying to actually just use true. You're going to have to do like an into or an as for that. Okay. Now, how can we use them? There's a couple different ways to use these. Here, I'll bring this back over to there. Just add you in. Booleans can be used in just like standard if statements. So just like if true, for example, is perfectly fine, or if we have it in a variable, it will extract the value of that variable and then to be what that Boolean is. We can just use the Boolean literal, or we can use something that turns into a Boolean, like for example, bitwise operators, or we can also do just like greater than, less than, any of those sort of like checks. So if I do something like true and true, this is gonna be true. So I can just do like a debug. Yeah, true and true. And then we see true and true happens. And of course, we can also use and for checking like, hey, two different things, are you equal to each other? The bitwise operator does work beyond Booleans because essentially, does work on Booleans, because they're essentially binary numbers, 1 or 0 behind the scenes. So that's why we can compare. Okay, 1 and 1 in the same position. Well, that's true then. Or would then be false, and this is not going to work for us. Although I still get this, or we need them to be false if I want that to work. So false. Now we won't get that. There you go. Okay, so we can do the if statement like this. We can also do the match statement. So if I match on some kind of Boolean, so if I do like let, I don't know, like something is equal to 5 greater than 3, which turns that into a Boolean. I can now match on something. And if I fill out the match arms, we'll see that it's just true or false that we're checking for here. We don't have to check for anything else. These are all of the arms that could possibly be. And then finally, it comes assertions. So if we do an assert, not an assert equal, but just an assert, anything in here must be just a Boolean. So we can put true and you'll be fine. If I put false in here, it's going to throw an error. It's going to panic essentially. So I throw you in there. Where did you panic? Oh, not yet implemented. Where do I have a not yet implemented? Line 11. Oh, my to-dos. Oops. I totally forgot I had that in there. Let's do this again. So we run that, and yeah, everything is fine. And then if I turn this into a false, then nothing will be fine. And we're going to get a big honking crash here. So we get our panic because the assertion was supposed to be true, but it's false. So, and then we get our stack trace. These assertions can actually be really helpful. You can put them into live code, especially for things that are never supposed to fail. That way you can find out if they're failing really, really quickly. Sometimes you want to crash if something like that happens, and that can be helpful. Now, finally, we have methods. There is a nightly method that we don't have available to us right now, but it's very similar to the other method that we do have. So let's dig into that a little bit. So there's a method called then for us. And it's a little bit interesting. I spent a little tiny bit of time trying to think of like a good example of when to use it. But for right now, I think it's best to just be aware that it exists. And then if a situation comes up where you really want to convert your Boolean to an actual value that's not a Boolean, but anything else, then, well, this is the tool to pull out. Okay, so let's say we have something that's a Boolean. We already have our something right here. Let's just use that. So I want to be let something else is gonna be, we're gonna take this something, and then we can just run this dot then method on it. Dot then takes a function, so a callback, or callback, no, that's JavaScript, closure. It takes a closure, and then whatever we return from here is gonna be inside of an option, so a sum, if it's true, or a none if it's false. And I can return whatever I want. So I can turn this into a number, like an F32 number. I can say, hey, I want this to be 1.0 F32. And even though we couldn't cast it into a 1.0 automatically, well, now I've done it. We can see here that something else is now an option with an F32 inside. I can put this into a string. So I can do a string from with this like hello in it. And now we have this option with a string inside. So basically anything that we want can now, like, we can convert that from a Boolean to some arbitrary value, which I'm sure could be helpful, but I haven't thought of a good way to use it yet. As I mentioned, just have it in your repertoire, know that it exists, and then you can come back and look at the documentation when you need to. All right, that's everything for Booleans. Thank you so much, and I'll see you in the next video. Bye. All right. Have I recorded those two? Oh, I did record those two. Okay. So the most recent one was this one. This is bools. This is arrays. Okay. Cares. Or chars. How do you all pronounce it? Do you pronounce it care or char? I've always said care, for like short for character. But I've also heard some people call it char. All right, a character type. The char type represents a single character. More specifically, since character isn't well-defined concept in Unicode, char is a Unicode scalar value, which is similar to, but not the same as a Unicode code point. So I think like the big thing about this, and I think the book goes into this quite a bit, is that a character doesn't mean just like eight bits. It's not like the letter A. It could be the letter A, but it could also be like this, like a kanji, from, is that Japanese? Or like, is it Hindi? I forget like the names of the written languages. But those sometimes take up more than one character for a character. So this character is representative of like the character in the end, and therefore sometimes takes up a little bit more space than what you might expect. I know it's a little bit confusing. This documentation describes a number of methods and trait implementations on a char type. For technical reasons, there is additional separate documentation in the standard char module as well. Is that something we're going to be going over? There. Okay, so char and primitive. Those are functions. Type definitions. Still type definitions. Constants. Structs. Wait, is there a char struct? Oh, chars. Char struct. Okay. For like iterating through characters. Okay, so what was it saying? Standard char module. Is there modules? No. Okay. Huh, interesting. Module standard char. Oh, primitive type. That's what it is. Standard char. Okay, so hold on. Oh, you're not listed as standard char in this like all list. So we're gonna have to go over that here too. Okay, so let's open you up. So more documentation and the standard char module. Char is always 4 bytes in size. Right, okay, so 4 bytes in size with each byte being made up of 8 bits. And like each one of these only needs to be 1 byte, but they're gonna be 4 bytes regardless. This is a different representation than a given character would have as part of a string. For example, these 5 elements times 4 bytes for each element. Oh, we can get standard memory size of. Oh, cool. Okay, so that's nice. We can get the memory size of something. That S equals a string from the same thing. If I try to run you. That's cool. Thank you so much for that. Oh, I guess it's just showing this. It's like 20 and 5. That it's 20 bytes for if we're just doing everything by characters, and it's 5 bytes for a like an actual full string. So if you want to be small memory wise, use strings. But if we're only going to work with like a single character, then just use char. So char is always 4 bytes in size, regardless what is stored in it. I don't know, like the recording like the individual videos thing, I may not continue with that. I don't know if that like how helpful that actually is to people. I'll probably like put up a couple from like the couple we did today, and then I'll just like see, hey, do you want me to continue doing this or not? Let's see. Hello. Hello, Dota. Your local startup center, there are a few businesses you're less disappointed with. That sounds good. Guess it bothers you because you want new tech startups in town. Oh, yeah. It's nice to have those, but I mean, maybe there's some that like aren't in the startup center. Like over here, there are plenty. There are a lot. Denver has become a hub of startups. Yeah, we aren't really a tech hub. I can see that. A lot of people don't think that they're tech companies, when unfortunately every company is now kind of a tech company to some degree. You definitely need that startup hub to feed the bigger companies. It helps, yeah. A lot of the bigger companies also rely upon purchasing the startups as a way of like getting new, like changing themselves quickly, because it can take a lot to spin up new things and it can be dangerous for them. So they often don't. They just would rather purchase a company that's already proven how to do something. Okay, so yeah, for example, here is this. That E character is 1 Unicode point, whereas E itself is 2 Unicode points. Right, yeah. It's this entire like U plus OOE9 Latin small character E with acute. They hired a CEO who was 1 month pregnant, who is rumored to not be taking the job 8 months later. Huh, interesting. I mean, it's like, I don't know, that also sounds like something of like in America, you would just have like, well, you're not gonna take time off for that because that, well, America. But yeah, like, the last 6 months, they hosted exactly 1 event, which you attended, and was the only person not allowed to ask a question. What? Oh, I'm so sorry. That sucks. Let's see. Some cares next. I kind of want to try some of these out. Do you actually have to do... Okay, so we do this chars. Oh, because like chars next is like the next in chars. So we have this that turns into like the individual characters. So if we do can I copy you and will you copy that incorrectly? Hey, that works. Okay, so we can see this. Now if I try to debug chars, let's just make sure that this is working fine. Okay, so I see that debugged out there like that. Great. Now I want to do this as like dot chars. Now it's an actual, okay, so there's a data structure chars. So now if I look at that, the data structure is essentially a tuple with an array inside, but it's still this like only one E. So then if I do next, it's okay, the option of this one. If I do another one, it's gonna be none. So basically it's not like each individual part of the E. It's gonna be the, like that entire thing. Now I can go from like a string to get chars, but it's interesting that, oh, it is a string with characters. I didn't notice that. If I do this, can I still get chars off of it? No, because chars is not a thing. Got it. Okay, so yeah, chars is an iterator. That's what it looked like. Chars is an iterator or a struct. I want to say it's a struct. Oh, it's an iterator. Here it is. It's an iterator. Also, good morning, KJH6. Oh, wait, did I already say good morning to you? I think I did. I did. Sorry. Yeah, it's an iterator that implements that, struct that implements the iterator trait. I think it's just an iterator that like a method returns off of strings or, yeah, off of strings or string slices. Okay, so let's try to like, for example, that. And we'll go over that iterator later because I think that's going to be something I should really. Yeah, this. Oh, it's listed under the struct section. That's why I thought it might have been a struct. Oh, look at this. There is a struct for it. But it's still an iterator. So it's a struct iterator. Got it. Okay. Yeah, in Rust, an iterator is something that implements the iterator trait. Got it. For some reason, I thought it was something like an iterator was just its own thing separate from structs. But I guess it does make sense that a struct, it's just something implementing that. Are there courses in the Rust language? So there's been some people who have like dropped by saying like, hey, I'm taking a Rust course in my college class. So that, you know, yes, but I don't know where they are, like how good they are. There's, I don't know. I don't know. You didn't mean like that? Are you talking about like paid courses that you can take? There probably are. There are courses in TypeScript that are really good. I want to say that Front-End Masters announced a Rust course. Here it is. Richard Feldman has a Rust programming language course. I do like Front-End Masters. I think they're pretty good. And of course, after that, there's just like the books, which are also could be considered a course, except it's books. Yeah. But then besides that, I think there's just like lots of YouTube videos, like people like me who have created some like courses on YouTube, but they're not official. You can't pay for them, that kind of stuff. I might create a course, like an actual paid for course someday, but I feel like I need to get my skills up a little bit more before I pull that trigger. Wait, what? So the contents of the first string above will fit into a char. So that's that. While the contents of the second string will not. What? I'm confused. Can I not set that? Hold on. So let chars equals this. If I debug chars, and you don't need to be mutable, you should work. Yeah, you're fine. Togglebit rating with a party of 130. Welcome, 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 Togglebit, and welcome everybody else. Togglebit, well, raid and run. Well, thank you so much, Togglebit, for hanging out. Well, hanging out, not really, but for the raid, and have a good meal and a rest and whatever else you're doing. For everyone else, welcome. And then there was a toggle raid. Yes. Hello, Otfrost. Rodolfo Silva, the A-Wrapped, Mr. Martin. Hello, everybody. How are you all doing today? And what was Togglebit working on? Hello, Mr. Martin. We are doing a deep dive into the standard library of Rust. So we've gone through, I discovered that Rust has in just like the standard library documentation, there's this sees all standard items and then just all of these things. So I'm starting with primitives and I'm just going top to bottom. We are on character now. And then we're just sort of like diving into it and taking a look at it. Baraduda, hello, good morning. Nailland47 says, have a nice time to Togglebit. Okay, so this sentence is a little bit confusing to me. Is it talking about like something up here? No, it's with this like sort of the L with the acute, oh sorry, the E with the acute on it still. But I don't know. Oh, if I tried to like make it a, no, I'm still confused. Oh, evening from Japan. Well, welcome, welcome, welcome. It is morning here. The E's look the same, but they have a different Unicode representations. Yeah, they should. Oh, they do, don't they? Hold on. So Latin with an acute. Okay, hold on. Stupid language. So if I do that, save, we're fine. So this is E acute. And then if we do let E Latin equals, and we're gonna throw this one in. Okay. Character literal may only contain one code point. If you meant to write a string literal, use double quotes. Okay. So that's the problem. Why you do this? Yeah, human language. If only we didn't do anything like that. Bagosh Copet redeemed Pet the Cat. I don't have time to go grab Zilby. And I don't think he's down here today. He's been avoiding down here recently ever since the green screen incident. So I'm gonna go ahead and refund you those points because I don't think he's gonna come down here before the end of the stream. Okay, so what do we do in this case? Another implication of the 4-byte fixed size of the char is that per char processing can end up a lot more memory. Right, that does make sense because it's 4 bytes per character, even if you don't need it to be. So string, we have this entire string. We then get our characters, collect them into a vector, and then we can get the size of these, and we can see that S is just 12 bytes in size, but once we turn them into characters, it's 32 bytes of size. Because like, hey, this is 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes, and it doesn't really need to be. These probably just need to be 1 byte, really, except for this one, which is going to be something else. Like what, 2, 3, 4 bytes? So, okay. Some languages characters are more than 1 code point, which means that not be stored inside a char. Then I think we can give this of like doesn't work. Totally fine. Doesn't work. And actually, I think we can even see the error. that. And I think so just sort of like things to be aware of. This is important to be aware of, since if we turn a string into characters, may be taking way more memory up than we need to. So the examples here would be, let's turn that off. If we have something like let my like hello equal to, we'll just do hello owns. Okay, so that gives us a full string here. And then this is going to be 1, 2, 3, 4, 5 bytes. And then if I break this into characters, just let hello chars, it's going to be equal to hello.chars. You're not 5 bytes. You're going to be 1, 2, 3, 4, 5 times 4, 20 bytes. That's it. Like, it's just instantly ballooned up in memory space. It doesn't need that much memory, but each character is set to 4 bytes, minimum and maximum, regardless if it needs to take that space up. So something good to be aware of. Okay. Then, implementations. Okay, so there's some constants here that we can work with. There's a max, so the highest valid code point a char can have. A char is a Unicode scalar value, which means that it is a code point, but only ones within certain range. Max is the highest valid code point that's a valid Unicode scalar value. Let's go look at like code point. Oh, this is from Unicode. Code point. Any value in the Unicode code space, that is the range of integers from 0 to 10 FFFF. Not all code points are assigned to encoded characters. Not like super helpful. And there's this Unicode scalar value, which is back to this. Any Unicode code point except high surrogate and low surrogate code points. In other words, the ranges of integers to 0 to D7FF and E000 to 10 FFFF inclusive. Still not super helpful and like need to grok it right away. However, there's this constant that we can do here. So off of char, I should be able to do something like debug char max. We'll run you. And here we can see this max is this 10 FFFF. S-U, is that number? Can I like cast that? It's like Yeah, as a U32. Sure, do that. One 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 four 111. Is that bits? The highest valid code point a character can have. I guess like that's the maximum size that that thing can have. I haven't really thought in code points ever, but I've not really needed to for like most of the stuff that I've done. But okay, so these are the methods. I do find, okay, where's the max on the left here? Oh, no, not at all. So you just, okay, Constantine. I think it's the character with the biggest Unicode value. It must be. And I think it must be bits. So hold on. If we take 1114111 and divide by 8. No, that can't be bits because then that would be 139,000 bytes. That doesn't make sense. I don't know how like actually. I mean, we know it has to be like a maximum of four bytes. Oh, so can it be divided by like the 4? I guess it's just something like this is something different than like the amount of space that it takes up. I don't know what this max really is. So something I still don't understand. Char max is the character with the biggest number. Well, yeah. I guess I still don't understand what like can I have a character that has like that biggest number? Like what's the largest Unicode character that we can find? Can I Google for that? Largest character Unicode. Like, is there an example of that? Why is that in the weather group? Oh, KJH, you try to send a link. Let's see where that was from. Oh, from Unicode table. Okay, sorry about that. Let me grab that really quickly. Here that is. Okay, so U plus. Here it is. 10FFF is the actual thing. Okay, so can I store this like that? So can I do let long hair equals that? Stop trying to give me those documentations. That's not helpful. Okay, so no, I can't. Do I have to backslash it? No. I was kind of hoping that I could just do this one. I guess I have to copy it directly. So can I just copy you? Well, that didn't like that. Oh, okay, let's try that. Let's try that one. So backslash u, and then with curly brackets around it. Then lowercase u. No, it doesn't like that either. Now it shows this as like the way to do that, but that's, oh wait, in quotes, in quotes. Oh, come on. You're not gonna let me quote. There we go. So now if I debug this out, I mean, okay, so it's stored in there and it's perfectly legal to store that in there, but it's it won't actually print out what it's supposed to look like according to terminal. I guess like my terminal, I don't have that font for that, but that's interesting. And it is, as we can see, pretty long. Okay. Everybody, I hate to do this, but it's after 10:30. Oh, so 10:30? It's after 9:30 my time, and that means I have stand-up coming up for my team very shortly. So I am going to have to cut off our stream pretty soon.